This video deals with applying the rules for significant figures when doing multiplication and division. Again, the rule is relatively simple, but we'll try to walk you through a few examples to give you some idea of how these things work. The rule, again, simply stated is the most significant figures your answer can have is the least amount of significant figures of the numbers that you use to get the answer. What that means is you can't have an answer that's more precise than the numbers that you put into the calculation to get the answer. And again, we'll try to work through some pretty simple calculations to give you an idea of how to apply these rules. So our first one is going to be 4.001 times 23. So again, I punch that into my calculator, I get 92.023. So that number has 5 significant figures. We have a 0 in here, but it falls between two non-zeros on each side. So that is a total of 5. But what we have to do is look, what did we start with? This one, according to our rules, has 4 significant figures, and this one has 2. This is our limiting factor. Put a limiting factor, LF, right here. That means we can't have any more than 2 significant figures in our final answer. So this really becomes just simply 92. Again, it can't have any more precision than this. And then somebody might have measured this out to be 23 of some type of object or unit, and this was measured much more precise. I mean, maybe with the micrometer caliper if it was a distance or something, but to the nearest millimeter. And that's not going to be as useful to us if this was a distance, because this is not measured as precise. Let's give you another example. This time we'll use division. So we're going to say 115.8. This time divided by 12. And when we do this, we get some crazy, not a real big number, we just get 9.65. Now, again, that one looks like it should be pretty close to what it really should be, but again, when we look here, we have 1, 2, 3, 4 significant digits. Here we only have 2. So again, that is our limiting factor. I'll put that little LF after that, which means we can only have 2 significant figures in our final answer here. So I'm going to have to round this 6 up. This becomes 9.7 with the appropriate significant figures. So we have to make sure we can't have more precise answers than what we use to get the answer. Let's go to a clean sheet here and try another example. This time we're going to go, same idea, we're going to do some division. So we're going to go 5.234. Sorry about the messiness all of a sudden. We're going to take that and divide that by 1.2. Again, when I do this, I'm going to get a much bigger answer in terms of the decimals. I have 4.36166 repeating. So I'm just going to kind of stop that here and say 7. This would keep on going. I could have an infinite number of decimal places if I wanted to. But decimal places doesn't matter in this case. It's only the least number of significant figures put into this part of the problem is the most I can have down here in this part. So right here I have 1, 2, 3, 4 significant figures. Down here I only have 2 significant figures, which means I have to round this off to 2 sig figs, which in this case will now just simply be 4.4. So the rule really is pretty simple, as long as you remember that there's 2 types of rules, one for addition and subtraction, which we had talked about in an earlier video, and one here that deals with multiplication and division. Scientific notation a lot of times makes this a very easy process. Let's try one more example here. We're going to go 3.0 times 10 to the 8th. That is our speed of light. So I'm going to actually put that as a meters per second. And I'm going to divide this, which is something we'll do, especially when we get into mechanics. Maybe we want to know how far something can travel in a certain amount of time when they travel at the speed of light. So we're going to say, okay, our time is also going to be a big number. It's going to be 2.15 times 10 to the 10th seconds. All right, second is SEC. And what's nice about the scientific notation is we can see right away we have 2 significant figures here. We have 3 significant figures here. When I punch this in my calculator, I get 1.3953488. Now that's going to keep on going. I'm stopping with some of the decimals, but that's times 10 to the second. And again, with dimensional analysis, we find out that that is just simply in meters. We'll talk about that in a future video. But, you know, it's kind of easy to see. We had 2 significant figures here. We had 3 here. So the most we can have, again, is 2. And again, that would be because of this one up on top. That's our 2, which means we're going to have to round this 3 up. So my correct answer with the right significant figures here is 1.4 times 10 to the 2 meters. Notice our exponents aren't either of the original exponents we had. Those can change. Let your calculator do that work if you're not comfortable with that. A lot of people can just subtract one from the other and know that this should be a 2. But the bottom line is we can only have the same number of significant figures here. The most we can have here is 2, and that's because the least we had up here was 2. And that's our video lesson on significant figures in multiplication and division.